ఒక 1 minute ఉండండి తర్వాత రావట్లేదు. Hello students, am I visible? Is the screen visible? Yes. Okay. Hello students, am I visible? Is the screen? Okay. So yes, Pawan sir is on leave, so today I've come to take the class for you all. So today we'll see about genetic disorders. So we'll know about the classification of genetic disorders. So, what is the importance of or genetics as such? We will know whether, for infectious disorders or they're about nutritional diseases or to control them. Okay. So, yes. Now, if we take diseases like thalassemia, AIDS, and diabetes mellitus, if we see in this chart, we have in thalassemia, it is mostly due to genes. Okay, and in AIDS it is mostly due to environment surrounding us, and in diabetes mellitus it is almost due to both of it, like environment and the genes. Okay. Okay. So 2300 hereditary diseases are known. Then 25 to 40% of all cases treated by health services, and they explain incidence, cause, and clustering of cases in populations. Okay, now what is the definition of genetics? It is a study of heredity and its variation, endogenous factors of health and disease, interaction between nature and nature. Okay, so this is what genetics deals about. Human genetics includes classical genetics, clinical genetics, cytogenetics, genetic counseling, biochemical genetics, pharmacogenetics, molecular genetics, immunogenetics, behavioral genetics, population genetics, developmental genetics, reproductive genetics, ecogenetics, forensic genetics, and much more. Okay. Okay, so we will review whatever we learned when we were in school or in inter. Okay, okay. What is a chromosome? Okay, a chromosome is a linear strand made of DNA that carries genetic information. Okay, I hope all of you will brush up their knowledge with the slides. So the human chromosomes, there are 46. There are 22 pairs autosomes and one pair sex chromosomes. I know all of you all have, by hearted it, even if you all didn't understand, because this is a most important part in science. Okay, so this will just give a quick glance. Okay, so I know that all of you all have all these mitosis and meiosis in your mind very fresh. Okay, so mitosis, there are phases that you know that there's interphase where there are 46 chromosomes. Then you have prophase where chromosomes will get doubled to 92. Then you have prometaphase where nucleus dissolves and microtubules attach to centromeres. Then you have metaphase where chromosomes align at middle of the cell. Then you have anaphase where separated chromosomes are pulled apart. Then you have telophase where microtubules disappear and cell division begins. Then you have cytokinesis where two daughter cells form each with 46 chromosomes. Okay. Now coming to meiosis, where you have parent cell where which has parental homologue, paternal homologue and maternal homologue. Then you have prophase 1, then you have metaphase 1, anaphase 1, and you have all these will come under first cell division of meiosis. Okay, where is the same steps of mitosis will take place. Okay, then comes telophase 1 and prophase 2, where you get two daughter cells with half of the paternal homologue and maternal homologue. One part gets shifted. Okay, I hope you are very clear with this. I'm just going quickly. Next, you have this metaphase 2, then you have again anaphase 2 and telophase 2, where it gives four daughter cells. Okay. Now, a gene is a basic unit of heredity made of DNA and codes for a specific protein. There's you know what is loci and you know what is alleles. Okay, then all of you all must know all the. I mean, you'll be knowing this in 10th. And inter you guys will be reading all this in MBBS first year also. This is important for us. Then you know what are what is homozygous and what is heterozygous, and what is a dominant and what is recessive traits and all that. Okay, are you all able to remember all that and refreshing your knowledge? I hope so. 25 people. Okay. So you know this genotype versus what is a genotype, what is phenotype, and you know what are polygenes, and you have penetrance, which is expressivity, which is responsible for skip generations. Now we'll come to aberrations. What is a mutation? Mutation is a permanent change in genetic structure. It is an abnormality in the chromosome. Okay, that may be of two types: numerical, which is non-disjunction, which is either aneuploidy or polyploidy, and structural, which is translocation, deletion, duplication, inversion, isochromosomes, and mosaicism. Okay, all these are very important 2 marks answers, which I'm sure that all you people know what are they exactly. Now, coming to the classification. Okay. Now, genetic disorders can be classified as chromosomal abnormalities, Mendelian disorders, multifactorial disorders, mitochondrial disorders, and non-inherited genetic disorders. Okay. Now, chromosomal abnormalities. Chromosomal disorders are of two types: sex chromosomal and autosomal. Now, related to sex chromosomes, it is Klinefelter syndrome, XYY syndrome, Turner syndrome, and superfemale. Okay. Now, coming to the Klinefelter syndrome, it is seen in 1 in 1,000 males. Um, it is XXY or XXXY males. They are sterile. Gynecomastia is seen. Mental retardation is seen, and they are usually seen in babies born to older women. Okay. So the features that you can see here are frontal baldness absent, and a poor beard growth, tendency to grow fewer chest hairs, narrow shoulders, wide hips, female type pubic hair pattern, breast development, small testicular size, and long legs. Okay, now what is XYY syndrome? This is also seen in 1 in 1,000 males. They are over 6 feet tall, they are aggressive, and they show antisocial behavior. Now we'll see Turner syndrome. It is seen in 1 in 7,500 live born girls. This is XO female, infertile, webbed neck, coarctation of aorta, and mental retardation are seen in them. And what is a super female? Super female is XXX or XXXX, or you have 5X this, and they are female. Okay, then mental retardation is seen, and they have underdeveloped genitalia. Next, we have, I mean, examples of which are examples of genetic disorders related to autosomes. Okay, they are Down syndrome, Patau syndrome, Edwards syndrome, etc. This, I think, you will be learning more in pediatrics. But this is just a glance of what is genetics all about and what are the genetic diseases. Okay, so other name for Down syndrome is Mongolism. Incidence is 1 in 900, that is in Europe. Mm, Defect seen as extra chromosome on 21st pair. Okay, this you can see here, extra chromosome on 21st pair. These are common in women conceiving after 40 years of age. Now, coming to the clinical features of Down syndrome, they're mentally retarded. They have round head, tilted eye slits, malformed ears. They are more prone to infections. They have congenital heart disease, and they present with acute leukemia. And usually they are very pleasant and they love music. Okay. Now you see these normal palm creases. But in Down syndrome children, you will find only one crease or simian crease. Okay. Now coming to the Mendelian disorders. Incidence: the 1% of all live births. They are inherited according to the Mendelian laws, which are law of unit characters, law of dominance, and law of segregation. And there are mutations at individual loci. Mendelian or single gene disorders are of three types: autosomal dominant, autosomal recessive, and sex linked. Now, autosomal dominant inheritance. An individual with autosomal dominant trait will produce two types of gametes, half with normal alleles and half with mutant gene. Offspring of such individual have 50-50 chance of being affected irrespective of sex, provided other parent is normal. Now let us see in this. Affected father, unaffected mother. Okay. Affected father, if we see one pink and one green. Okay, so he's affected, and unaffected mother, there the recessive gene is pink and dominant gene is green. So then, what other types? What are the chances of their kids getting having the disease? Let's see. So, affected child. If it's a boy, he will be affected. Okay, because it is an autosomal dominant. Okay. Next, if they have a daughter, they'll be unaffected because mother is unaffected and half of the father's trait is unaffected. So you will have unaffected daughter. Next, the other son, if they have another son, he may be unaffected because he will get half from mother, half from father. Okay. So next is another daughter. She also can get affected, where you will get affected part of father and unaffected part of mother. So here in such an autosomal dominant inheritance, you will have the offspring will show 50-50 chance of having the disease. Okay, provided the other partner is normal or other parent is normal. I hope you all understood this. Okay, example for such a autosomal dominant disease is dominant inheritance are achondroplasia, Huntington's chorea, neurofibromatosis, polyposis coli, um, Marfan syndrome, retinoblastoma, and many other diseases are there. Now, achondroplasia. Achondroplasia, it is due to a mutation in fibroblast growth factor receptor gene 3. The clinical features are shortening of limbs, large head, kyphosis or lordosis, varus or valgus deformity in legs. Now, coming to the autosomal recessive inheritance. Now, both parents should be heterozygous. Each offspring of such parent has 1:4 chance of being affected. They occur sporadically in outwardly normal parents. Okay. So, unaffected carrier father, unaffected carrier mother. Okay. Now you see one is recessive gene and one is dominant gene. So they both the parents are carriers. Then the uh, one child is unaffected child. You get unaffected because other normal parts can come, and the other child may get unaffected carrier. That's because other unaffected part of father can come down and affected part of mother can come down. So you get unaffected carrier child. Next, unaffected carrier child, or a son, where the affected part of father and unaffected part of mother can come down. And you have affected child, where the both affected part of father and affected part of mother come down to daughter. So you have over here 1:4 chance of being affected. Okay. Example for such autosomal recessive inheritance are cystic fibrosis, phenylketonuria, albinism, Tay-Sachs, alkaptonuria, fibrocystic disease of pancreas, hemoglobinopathies. Now, most important, cystic fibrosis. I think you all have learned this for your pathology exam because it's a 4 marks answer. I remember this. Okay, so 2.5 to 5 per thousand live births. Cystic fibrosis is seen. Then it is due to a mutant CFTR gene. Okay. It affects the respiratory system and GIT. Recognized and treated earlier. Life expectancy in developed countries is about 30 years. So you see this chromosome 7. CFTR gene is on chromosome 7. Okay. So cystic fibrosis is a hereditary disorder characterized by lung condition and infection and malabsorption of nutrients by the pancreas. And mutant CFTR channel does not move chloride ions, causes sticky mucus to build up on the outside of the cell. Okay. Now, this is a normal CFTR channel which moves chloride ions to the outside of the cell. Over here, the CFTR channel, because of this mutation in CFTR gene, the channel will not move and all the mucus will get stuck. Okay. Now, coming to sex-linked inheritance. Sex-linked traits are two types: recessive sex-linked and dominant sex-linked. Recessive sex-linked. Um, Now, if a father is with hemophilia and a mother is not a carrier, okay, she's normal. Then you have a son without hemophilia where he gets XY, from father and from mother and father Y from father, and daughter will be a carrier because she gets one X from father and one X from mother. Then you have a son without hemophilia where you get one X from mother and Y from father. Then again you have a daughter who is a carrier because one X from father and one X from mother. Next, if the father is without hemophilia and mother is a carrier for hemophilia gene. Okay. Now, mm, the son will be without hemophilia, daughter will be a carrier for hemophilia, and the son has hemophilia because he'll get one X from carrier mother, Y from father. So he will have hemophilia. Next, daughter, and she does not carry any hemophilia gene. Okay. So mutant gene on X chromosome in males will express readily due to absence of normal allele, while in females will not express in presence of normal allele. If affected, male marries normal female, all daughters are carriers and sons escape. If carrier female marries normal male, daughters have 50% chance to be carriers and 50% normal are 50% carriers will be there and 50% will be normal, and sons will be 50% affected and 50% normal. Okay. Example for such disease is hemophilia A and B, Duchenne muscular dystrophy, color blindness, GCPD deficiency, hydrocephalus, and retinitis pigmentosa. Now, coming to hemophilia. 15 to 20 per 1 lakh males are born. Absence, decrease, or reducing functioning of blood coagulating factors 8 and 9. Clinical features are hemorrhage and hemarthrosis. Treatment is blood transfusions, plasma derivatives. Threat is hepatitis and AIDS because of the blood transfusions and plasma derivatives. Okay, so you see these excess of bruising in hemophilia. Now, next is Duchenne muscular dystrophy. It is due to decreased production of dystrophin, and the clinical features are battling gait by first decade, progressive difficulty in walking, bedridden, death is seen in most of the cases. Carrier females alone transmit the disease. Dominant X-linked. Affected male transmits the disease to all his daughters but none of his sons. Excess of females affected. Example: vitamin D resistant rickets, XG blood group, and familial hypophosphatemia. Now, X-linked dominant affected father. Affected father, we have X-linked dominant on X chromosome. Then mother is unaffected mother. Then you will have unaffected son, where X from mother, Y from father. Then I have affected daughter, where you have one X from father, one X from mother. Unaffected son, one X from father, one X from mother. X from mother and Y from father. You have affected daughter, where you have one X from father and one X from mother. Okay. Now, multifactorial disorders. Diseases whose phenotype is strongly influenced by the action of mutant alleles at several loci acting in concert. Incidence: the higher than chromosomal and Mendelian disorders. Example are adult onset hypertension, schizophrenia, mental retardation, duodenal ulcer, IHD, diabetes, congenital heart malformation, congenital neural tube defects, which are spina bifida and anencephaly. Inherited predisposition is suspected when a disease has early onset, similarly affected parents or siblings, occurrence in less commonly affected sex or IHD in female, or ischemic heart disease in female. And high incidence in ethnic groups, like Spina bifida and Irish populations. By age of 25, 1 in 20 individuals of population are affected. Complex inheritance. Environmental factors involved, example, smoking, diet, obesity, and ischemic heart disease. Okay, where the IHT increases with smoking, alcohol, drug abuse, age, gender, family history, obesity, high cholesterol intake, hypertension, and stress. Next, coming to the mitochondrial disorders. Mutations in mitochondrial DNA uh, leads to mitochondrial disorders. Since mitochondria are cell organs, they are inherited from mother as zygote derived cytoplasm from ovum. Then you have example liver optic atrophy, infantile bilateral striated neurosis, and Kearns-Sayre syndrome. Remember these three because when you appear for NEET, this will be the most important bit for your preparation. Okay. So remember this. There are many times same question have been asked on this mitochondrial disorders. Okay, so let's see. Girl is affected with mitochondrial disorder, and then you have the same, kind of affected daughters or carriers. Hmm. Okay. Next, non-inherited genetic disorders. They are normal at birth, acquired diseases. Genes are damaged or genome altered by environmental factors like radiation or chemicals, viruses. Example are cancers and AIDS. Okay. So, how can we prevent all these genetic disorders? I mean, prevention is there for everything, but there, I don't know, there will be uh, people will be very hesitant to take that prevention. I don't know. So yes, this genetic counseling is there. It started since long, where the if the father or mother have any disease, they will be counseling them. What are the chances that their kid might have? Then there is this gene therapy, which is not so much into the field, but yes, in of course in foreign they might be doing this. Then you have this Human Genome Project where they're still searching or still doing research in how a nucleus or chromosome or how DNA is still working on, or what are the changes that it can take place where if there's a mutation. All these are still going on. So thank you for your time and listening to the class. Okay, so I have an announcement to make. Yes, when I spoke about IHT and obesity and other hypertension uh, things. So I'm doing a study on the level of physical activity among medical students and the depression or how was their mental status during COVID-19, during the lockdown, and now also during this COVID-19 pandemic. From third year, I think I got only 30 or 36 um, uh, forms, filled Google forms. How much is your strength? How much is the class strength? Can uh, can roll number 28 tell me? He's the last one to enter, so I think he heard me. Roll number 28, how much is your class strength? I will have to call out names and ask you all. Did you all fill out the form? Did you all fill out the form? Do you all want it? I don't want it. I don't want to disturb anybody's, telling out names. Please, please do fill out the forms. If you fill out the forms, we are going to give attendance for this class. Otherwise, all of you all will be absent for today's class and last week's class. Okay, so please, please fill the form. And can anybody who is online, I can see four people online or three people online. Can any one of you all answer how much is your strength, your class strength? Yeah, only 36 have filled the form. Only 36 have filled the form. So please, by the end of the day, I request whoever did not fill the form, please fill it. I will need. I expect more 50. So I'll expect 80 from you people. Yeah. So 80 or 90, I would be expecting from you guys. 99. Okay. Thank you. Thank you so much. Whoever responded, thank you. 99 is your strength. So please do fill the form. Whoever did not fill the form, please do fill it. I will. I did not. Till now, I did not tell anybody, or I did not. Your juniors have sent me the filled forms. I did not tell them that they will not get any attendance, but still, without telling that they have filled the forms, you people being exam going batch, I don't know, like what was going on in your head? Like it's okay, we will not fill. We'll see what will happen to us. Is that your attitude? So till now, I didn't use this attendance thing because I thought you all are mature enough to do such survey or questionnaire that just takes 5 to 10 minutes of your time. I understand you are online with all these classes from morning to evening, but you have weekends, you have Saturday, you have Sunday, you have holidays in between. Now you won't even travel by buses. You have 2 hours extra per day in your time now. So now now I have to tell this. You will not get attendance for today's and last week's class if I will not get the remaining people's forms. Okay. Okay. Thank you. Thank you so much.